If you've watched the last video, you'll understand that the Triassic period was a wild era in the evolution of terrestrial vertebrates. The only regret is that the later mass extinction wiped all of this from Earth's history. However, the Triassic still sent messengers across time and space, and in them we can feel the traces of that era. That brings us to the stars of today's story, turtles. Yet, the evolutionary path of turtles has become a major challenge in paleontology. In 1887, German scientists identified a new prehistoric creature. Anyone who sees these fossils can recognize that they come from a turtle. It was named Odontochelys. The discovery of Odontochelys tells us that turtles already looked like they do today during the late Triassic, around 210 million years ago. However, looking so similar to modern turtles also raised other questions. Mainly, how did they evolve into this form? Initially, paleontologists speculated that the ancestors of turtles might be related to a group of Permian reptiles known as Pareiasaurs. Many Pareiasaur fossils show an evolutionary trend toward a hardened back, similar to a turtle shell. For example, Anthodon, whose back had evolved into something very similar to a turtle shell. Considering that Anthodon's main predators were Gorgonopsia, strengthening armor was a perfect adaptation against these agile and swift predators. This theory seemed logically perfect, so until the end of the last century, the idea that turtles originated from Pareiasaurs was the mainstream view in the academic world. It wasn't until 2008 when a new fossil was unearthed in China called Odontochelys. Its appearance was essentially telling paleontologists that most of the theories from the previous 100 years were fundamentally wrong, because Odontochelys, in every aspect, seemed like a turtle that was only halfway through evolution. It had only a partial turtle shell, and this half shell was located on its belly. This indicated that turtles evolved a ventral shell first and then later developed a dorsal shell. This fundamentally undermined the foundational theory that Pareiasaurs with hardened backs were the ancestors of turtles. Furthermore, Odontochelys had teeth in its mouth. Some friends may not have noticed, but modern turtles do not have teeth. They have structures resembling bird beaks. Odontochelys revealed that the ancestors of turtles had distinct sharp teeth adapted for eating meat, which was a completely different dental morphology from the herbivorous teeth of Pareiasaurs. Therefore, the discovery of Odontochelys directly overturned all previous theories. Paleontologists embarked on a new journey to search for the ancestors of turtles once again. The spotlight began to shine on a fossil discovered in the 19th century in South Africa, known as Eunotosaurus. Eunotosaurus was also a reptilian creature from the Permian period, and various pieces of evidence suggested that it was highly skilled at digging. This led to the emergence of a new theory of turtle shell evolution. Ancestors of turtles, similar to Eunotosaurus, widened and thickened their ribs and sternum to improve digging efficiency by lowering their center of gravity. These changes are beneficial for animals that frequently dig, like armadillos and pangolins, and can be observed in their bodies. However, this adaptation came at the cost of reduced flexibility, prompting them to shift towards the evolution of reinforced armor. They fused their ribs into a solid structure and relied on robust armor to defend against threats. Over time, this evolutionary path led to the turtles we see today. Subsequently, in 2015, paleontologists in Germany made another discovery, a primitive turtle fossil dating back to 240 million years ago, which they named Pareiasaurs. This fossil provided crucial evidence for the origin of turtles. Pareiasaurs had even wider ribs than Eunotosaurus, and its sternum had partially fused, showing a trend towards the development of a ventral shell. It served as a bridge in the evolutionary lineage between Eunotosaurus and Odontochelys, making the theory appear almost perfect. Just when paleontologists believed they had uncovered the evolutionary path of turtles, a group of molecular biologists suddenly disrupted everything. They analyzed the genes of many reptiles and found that during the time when Eunotosaurus lived, the ancestors of turtles had not yet diverged from the ancestors of crocodiles and birds. Furthermore, further examination of Eunotosaurus's bones revealed that the earlier paleontologists' analysis was not comprehensive. They had unintentionally overlooked many features that distinguished it from turtles. This once again rendered the evolution of turtles a mystery. In 2018, another primitive turtle fossil was unearthed in China, and paleontologists named it Eunotochelis. The appearance of Eunotochelis threw the entire evolutionary history of turtles into complete disarray. Normally, turtles possess two crucial evolutionary features: a turtle shell and a beak. As previously mentioned, Odontochelys had a partial turtle shell but lacked a beak, while Eunotochelis had a partial beak but lacked a turtle shell. This left paleontologists in a quandary. Since it was established that Eunotosaurus was not the ancestor of turtles, the evolutionary lineage of turtles has remained unresolved. Now, with the discovery of Eunotochelis, the puzzle has become even more complex. As people found themselves caught in the whirlwind of turtle evolution, a third theory emerged regarding the evolution of turtles. The locations where fossils like Odontochelys, Eunotochelis, and Pareiasaurs were unearthed were once situated along the coastline of an ancient ocean called the Tethys Ocean over 200 million years ago. This region was warm, fertile, and filled with islands, much like present-day Indonesia. Many of these primitive turtles displayed adaptations for an aquatic lifestyle, likely inhabiting freshwater river mouths and similar environments. Simultaneously, this marine environment was home to numerous top predators, such as the Ichthyosauria. During that era, Ichthyosauria were essentially the fastest-swimming water creatures, although their bite force was slightly weaker. Consequently, many medium to large-sized animals opted for the path of enhancing their armor to defend against Ichthyosauria threats. In fact, within the same marine environment, there were many animals with lifestyles similar to turtles that also donned heavy armor, such as Siinosaurus fargus. While it may look like a turtle, Siinosaurus fargus is not a turtle. Turtle ancestors likely underwent the evolution of their shells under similar survival pressures. They initially strengthened their ventral shells to resist attacks from Ichthyosauria from below. As they started diving more frequently, they began fusing their already broad ribs into dorsal shells to prevent Ichthyosauria from biting through them entirely. However, paleontologists might also consider that someday in the future, a peculiar and unusual primitive turtle fossil could be discovered, completely overturning all these theories. But that's the nature of paleontology. Paleontologists are dealing with a fragmented and shattered ancient book. Nobody knows what surprises the missing and damaged pages might hold for us. What we do know is that since then, the survival of turtles has not faced significant setbacks. During the Cretaceous period, there was even Archaeopteryx, which could reach lengths of up to 4 meters and weigh over 2 tons. And in the rainforests of South America, from around 9 to 5 million years ago, there was Stupendemys geographicus, which could reach lengths of up to 5 meters and weigh over 6 tons. Until today, turtles have made their presence felt both in the oceans and on land, emerging as successful animal winners with varied diets that include both herbivorous and carnivorous tendencies. If you've watched my previous videos, You'll notice that since the end Devonian mass extinction, there have been hardly any successful examples of vertebrates following the path of strengthening armor. Whether it's the Triassic Atosauria and Plecodontia or the Cretaceous Ankylosauridae, they all disappeared forever due to brutal natural selection and mass extinctions. It seems like turtles are the sole victors on the path of enhancing their armor. With their robust shells and diverse diets, they have endured numerous catastrophic extinction events, outcompeted many competitors, and become one of the most widely distributed groups of animals in the world today. Their mysterious origin is undoubtedly one of the most enigmatic evolutionary wonders in the history of animal evolution. This is Ancient Discovery. See you next video.